Hello everyone, Peter Newman with you. In AHRI Insight this week we're talking about some of Danica Goggin's research into 2,4-D. Danica's been studying 2,4-D for years. This research was funded by ARC and Nufarm, and she's looking into resistance mechanisms in plants like wild radish. Now what she found in this research is that wild radish resistance to 2,4-D is not metabolic resistance. There are other mechanisms. That's the short story. The longer story is pretty interesting. There's quite a bit of information about how 2,4-D is tolerated by plants. So let's take a little bit of a look at the longer story. Firstly, let's talk about the grasses and our cereal type crops, our monocot species. One of the ways they tolerate 2,4-D is by metabolic resistance. So let's have a look at that. So we have our 2,4-D molecule here, 2,4-dichlorophenoxyacetic acid. This is the acetate over here. This is the chlorines bound onto the benzene rings at positions 2 and 4. So one of the ways that our grass species, our monocots, tolerate 2,4-D is the use of P450 and GT enzymes. P450 is short for cytochrome P450 monooxygenase. It adds one oxygen onto things and then a sugar can come and bind. So a P450 comes and adds an oxygen onto the ring here. It actually puts it on there, and this chlorine actually then moves up to here. So it actually becomes 2,5-D, and now we have an oxygen bound onto the ring. Then another enzyme comes along called a GT, a glucosyl transferase. It adds glucose onto things and joins a sugar on to the oxygen here, so a glucose. So now we have a great big molecule. It's got this great big glucose hanging off the end of it, and our chlorine is in the wrong position and it no longer has herbicidal activity. So that is how our grass species, one of the ways they tolerate herbicides like 2,4-D. Now let's take a look at wild radish. Danica's been working on the wild radish resistance mechanism for a long time now. A few years ago she worked with a couple of populations and found that they were resistant to 2,4-D by reduced movement of 2,4-D between the cells. So she then went and studied some more populations just to confirm that that was the only mechanism, and found that there was about 5 of them had that same reduced movement mechanism, but then there was something else. There's a different mechanism going on. So she then had to go and look deeper to find out what is that something else mechanism. One of the things that she did was have a look to see if it was metabolic resistance, like we've seen in lots of other weed species. So she found that it wasn't metabolic resistance, but it's a very interesting story. So have a look at this. So this is our 2,4-D molecule again. Now when this enters the wild radish plant, it looks like metabolic resistance is going on to start with. What happens is the first thing that happens is the wild radish uses a GT, a glucosyl transferase enzyme, to knock this acetate off the end here, and it joins on a sugar, a glucose, onto the enzyme, onto the molecule, the 2,4-D molecule, and turns it off. And so the 2,4-D is inactivated for a while, but then the cool bit is that a hydrolase enzyme then comes along and snips this sugar off, and then the acetate can join back on, and it's back to being 2,4-D again. And so while it looks like metabolic resistance has started, another process actually happens, joins the acetate back on, it's back to being 2,4-D, and it's back to being the 2,4-D herbicide that can wreak havoc in the cells. So why do plants do this? Well, this is a natural thing that is happening in plants all the time. Remember that 2,4-D is an auxinic herbicide, it's an auxin mimic. Auxins are plant growth regulators. They are regulating the amount of growth going on in the cell. They get turned on and off all the time. One of the ways the plant turns them on and off is this. It joins on a glucose and then knocks it off again. So that is the way a plant can regulate the natural levels of auxin in the cells, and is also the way it behaves when 2,4-D enters a plant like a wild radish. So for more information, take a look at AHRI Insight.